Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at the last day for the March Daily LeetCode Challenge. I hope you would have enjoyed the questions till now we have seen in March, and this is going to be the last question. If you solve this question, you'll get the badge. And coming to today's question, it's again going to be hard question. From the last 4 days, including today, I will say we have seen three hard questions. And this is though it is marked hard, but if you see the acceptance rate, you will be shocked to know that it is around 70%. The reason is it's actually an easy question, but the thing is it's very difficult to get that idea. Once you get that idea, it will be very easy implementation. Okay, I will show you the same. And yeah, let's quickly begin. It's question 2551. Put marbles in bags. So what you all given is, see, these are the things that you are given. You're given the weights of the marbles and you're given to the k number of bags. Okay. The aim here is each one of these marbles should be put inside these bags. Okay. And none of the bags should remain empty after the allotment. Okay. That is each marble basically should be allotted to one of the bags in such a way that none of the bags are empty. That is the basic idea with which you're doing. And there are certain conditions. My request will be please read the question once because see, it's slightly lengthy question. I don't want to miss anything here. That's why I will say please go and read it out so that we only discuss the solutions. We only discuss the ideas basically, and not the the things given here. Because to understand this, you have to see the examples also, and there are multiple things here. I want that part to be completely independent of this video. Okay, I want you to do that so that in a context when such a question comes, you basically have some experience of how to deal with these questions, which things to remember. And like, see, after reading the question, if you're reading for the first time, what will happen is you will not even remember most of the part. Okay, that's why there is I will say a method, a basic a technique there. The technique is there in which that you will must only if you are doing that part. Okay, read the question, see the examples, or maybe see the example first and then read the question, something like that. And obviously you have to see the constraints also, so that once you read it, you should be able to get the whole picture. Okay, that is the basic idea. It's up to you, like if you see the example first then read the question, or if you see the constraint example first then read the question. It's up to you, whichever way you want. But that is something that you have to practice and do. Okay, it will differ from person to person, but yes, yeah, that is something that you have to master. So now coming to this question, here basically the thing is the whole question revolves around the topic of how we're dividing the marbles into the bags. Okay, so there are some rules which need to be followed. Okay, the first rule is that no bag should be empty. The second point is that, okay, for example, see, let us say I am putting these three marbles in one bag, then what will happen is there will be a score. Okay, there will be a score for each bag. So what we can say is the score will be basically, okay, 1 plus 5. Okay, that is the idea here is, let's say I'm putting marble number 1 and the index number 0 and the index number 2. Okay, these two things I'm putting in a bag. The idea here is if you put these two things in a bag, then all the marbles which are in between them, then those also should go to the same bag. Okay, that's what they are trying to mention in this question. Okay, if the ith marble and the jth marble are in a bag, then all marbles, okay, with an index between I and j indexes should also be in the same bag. That is a constraint given. And they're also talking about the cost. Okay, if the bag consists of all the marbles with index I and j inclusively, then the cost of the weight is going to be the weights of I plus weights of j. Okay, simple as that. So yep, so basically only the first and the last marble in basically, see, the idea here is if you talk about this, they are talking about a sub-array, right? So the idea here is only the first and the last element of the sub-array is actually going to contribute to the cost. Okay, and the score after distributing the marbles is the sum of the cost of all the k bags. Okay, so the idea here is whichever sub-arrays you are distributing to each of the bags, after that you will calculate the cost for each one of them, and the total cost is going to be the sum of cost of all the k bags. So you have to return the difference between maximum and the minimum scores among the marble distributions. I know this question, I can say there are three levels in this question. First, you have to understand what is the cost of each bag. Then you have to understand the cost, the total cost. Okay, the total cost, where we calculate the cost for all the bags. At last, you have to come and understand that we have to find the difference between the maximum and the minimum such cost possible. Okay, the total score is possible. We have to find the difference between the maximum and the minimum. So that is the question. Go through the examples, but there is a very important thing that I want to tell you is that, see, the idea here is it's something like that. Okay, yeah, if you now see what is happening, always if you see the first and the last marble, okay, the first and the last marble will always be part of, see, the idea here is, see, all the elements have to be covered and none of the bags can remain empty. So if you see this constraint, the first thing that should come to our mind is that the first marble and the last marble are always going to contribute to the answer. When I say answer, I mean to say, like, let us talk about only the max score for now. Okay, if you talk about the max score, always the first and the last marble are going to contribute for that, because if you take any subarray in such a way that you are covering all the elements, then always the first and the last element of the whole big array will always be contributing. Okay, then other than that, let's say we want k sub bags. Okay, we have k bags. Okay, in that case, if you talk about k bags, that means you have to divide the whole array into k parts. So in this case, if you see the screen that I'm presenting, the green, the red, the blue, and the orange one. Okay, so now in order to divide the array into k parts, we basically need k, I can say the dividers. Okay, k dividers. What are those dividers? See, the dividers, when I say, I mean to say like this. See, the 2 here and 3. Okay, the dividing is happening between that. Okay, the actual division is happening between them. Okay, so 2 and 3, so this particular pair is actually acting as a divider. Similarly, if you talk about 4 and 5, basically the division is happening between them, so they are acting as a divider. Okay, similarly 5 and 6 is acting as a divider. Now if you see the idea, see, we have to find the max score possible and to find the min score possible. Okay, in between both max and min score, one thing that is common is this first element and the last element. Okay, so first and last element will always be there of the answer. You can ignore both of them. That's what I'm trying to say. Okay, now how to find the max and the min? The idea here is, see, it's all depends on, okay, which divider we are going to consider. Okay, you can consider any divider, by the way. The divider could be anything. Okay, as simple as that. It could be anything, by the way. Okay, and always you have to see when you talk about divider, it's basically a pair. Okay, for example, 2 and 3 both together is a pair. Similarly 4 and 5, and similarly 5 and 6. Okay, so what you can do is try to see all the possible pairs, put them in a heap. Okay, put them in a heap, and then try to get the max, the pair which gives the max sum. Okay, as simple as that. Then that we will take, and that will form the max, the possible answer. We will subtract with the min possible answer. So that is going to be my approach. I hope you understood what I'm trying to do. The idea here is, see, we are going to see all possible dividers. When I say divider, I basically mean a pair. I will show you in my solution what I'm doing, but yeah, that is going to be the idea. Okay, so let us see what happens here. So what I've done is I've done heap implementation. Okay, I'm not going for the sorting one because, see, again, the idea is same. If you go for the sort, you have to sort the whole array, but we don't need to sort the whole array. We only need the k max and k means. Okay, so we'll use the heap in this case. Okay, as simple as that. Now, see, this is one of the edge cases. You will get to know about this when you solve the example number two. If you go to example number two, what you are seeing is, see, idea here is none of the bags should be empty. So at least one marrow should be there in each bag. Are you getting it? So if the number of elements and the k are same, in that case the answer is going to be zero, because there is only one possible division, and both the max and the min division is going to represent the same. Okay, it's going to represent the same. In that case, if you subtract max and min, you are going to get zero. Okay, since both max and min are, scores are same, so you are going to get zero when you subtract them. So that's why the answer will be zero. That's what we've done here. If k is equal to n, then you have to return 0. Okay, in that case you don't have to do any other calculation. You have to simply return 0. In every other case, what you have to do is, I'm creating array to store the max heap. Okay, this will act as a max heap, and this will act as a min heap. Okay, what I'm now doing is, see, I am going from 1 till n. Okay, while 1, see, the idea here is I will form the pairs. How the pairs will form? For every ith index, the pair will form with the I minus 1th index. Okay, that's how the pair will form. That's I'm starting from index number 1. Okay, so what I'm doing, see, both these are actually the same. There is only one small difference that I will tell you now. See, so what I'm basically doing is, if you see, I am trying to add the weights of I with weights of I minus 1. Okay, because if you see the way the things are implemented here. Okay, yeah, that's what they have done it here basically. See here, 2 plus 3, similarly 4 plus 5 is happening. So similarly, what I've done is, I'm trying to do the same. Okay, I'm doing weights of 5 plus weights of I minus 1. That's why I'm going to take all the possible pairs which are going to act as the dividers. Okay, now the only difference that I was talking about is, see, for the max heap. Okay, let's go for the min heap first. For the min heap, you don't have to do anything. Simply take the sum of both the elements, form a pair, the sum of the pair. Okay, and then add it to the heap. Okay, simple as that. This will form the min heap. Now for the max heap, see, the idea here is the heap queue library that we're using. In fact, even if you go for the Java, right, it has the priority queue library. Even for that, so idea here is, see, all the libraries, the way they are implemented is mostly in a min heap view. Okay, you won't get the max implementation because max heap can be implemented through the min heap. So how to do that? It's very simple. What you can do is, the way that you are, this particular sum, what you can do is, once you are getting the sum, multiply this with minus 1 and then append it. Okay, so the idea here is, see, the same thing I'm doing. If you see, this and this part are same, exactly same. Only difference here is I am multiplying this with minus 1. Okay, so this way what will happen is, the biggest element, let us say 8 is the biggest element. Now it will be multiplied with minus 1. So the biggest element, once multiplied with minus 1, will become the smallest element. Okay, so that way the same, the maximum we are trying to invent through a min heap. Okay, as simple as that. But the only thing is, here the elements will have a negative sign. So when you are taking them out, you have to ensure that you are removing the negative sign. Okay, that is the only thing that you have to ensure, right? Once this is done, what we'll do is, you can enable those print statements. You can enable this print, and then you try to see what the values are in that. You can do that. Currently I have not implemented that. Okay, so what I'm doing is, I'm creating answer equal to 0. Now, since we want only k minus 1, okay, if you see in this case, we see for k divisions, we need k minus 1 dividers. Okay, so that's what I've done it here. So I'm going from 1 till k. Okay, from 1 till index k. So see, idea here is, if you go from 0 till k, you are getting basically a whole k pairs, right? But we want k minus 1, so I'm going from index 1 till index k minus 1. Okay, from 1 till index k minus 1, remember that. Okay, so total we are getting k minus 1 pairs. So what I'm doing is, what I have to do is, from the heap, pop, see, this is the max heap, right? In the max heap, we have elements with negative sign. So when you are popping, see, this is, we are popping the element from the max heap. Okay, and once you are popped, you have to multiply this with the minus sign. So ideally what is happening is, this whole value that I'm highlighting in the screen currently, okay, this whole value basically represents the max possible, the divider which gives the max value. Okay, which contributes the max value to the answer. Okay, this will act in that way, right? Now this should be subtracted with the minimum possible divider value. Okay, the sum of the minimum possible divider. The idea here is, see, min heap basically means that the smallest value it will give. Okay, the divider which contributes the smallest to the answer, that will be, taken and popped out, and then that will be subtracted. So if you see the actual division that they're talking about, we are doing that. Okay, if you see the actual division they are talking about, right? I mean the subtraction they're talking about, we are doing that in this case. Okay, so idea here is we're taking the max possible and then we're subtracting from the min possible. Okay, in every case. So yep, that is how we are doing it, and then finally we return the answer. Okay, let me quickly run this and show it to you. As you can see, this is clearing all the test cases, and yep, right. So yeah, this was the code. And see, the idea here is, see, we are not sorting it. Okay, why we are not sorting it? Let us say you have 10 power 5 elements. So in this constraint, basically it's a 10 power 5. Okay, for 10 power 5 elements, let us say k equal to 10 or 9 or 8 or 50. Okay, in that case it will be a really waste of, programming code, I will say the programming compute power, that we are wasting our time in sorting k upon 10 power 5 elements, though it is not needed. Okay, we need only the top 5 elements. Similarly, we need only the bottom 5 elements. Okay, I mean to say the pairs. Okay, as simple as that. So for example, if there are 10 power 5 elements, so there are going to 10 power 5 minus 1 pairs. Okay, as simple as that. So we need only those. Okay, we don't need everything. We need only the top 5 or the top bottom 5. Okay, something like that. If k small, we should take use of it. Okay, we should make use of it, as simple as that, right? So that's why it is done. So overall, if you see, it is going to be n log n. But again, this I'm seeing overall, because there is no, clear distinction given between k and the length. Okay, k and n. But if someone guarantees that k is going to be very small and n is going to be, much larger than that, so yeah, this will be reduced. Okay, this will become k log n in that case. Okay, this will become k log n, because yeah, we are saving some time in that. So yeah, this could become k log n. But again, see, idea is very simple. Like every pair is pushed once. Okay, so that will in itself take n log n time, and then we are popping out only k values are popped. Okay, in every case, so that will take k log n time. Okay, so yeah, this will not look, see, in terms of space and time complexity, it may not look, greater one. Okay, it may not look great one compared to the sorting solution, but in terms of real, the coding efficiency, the time taken and all that factor, if you, see, for various inputs, there you will see the difference. Okay, because here we are only, yeah, we are pushing every pair, but we are only popping out those pairs which we need. Okay, like the 5 or something like that. Okay, so the idea here is we are not sorting everything, we are only sorting when we are really needing it. Okay, so you have to study about the heap structure to get to know about this property, but it's a really nice one. The idea here is, when you need only the top 5 elements or the top 10 elements, you need not sort the whole array which has around 10 power 5 elements. Okay, that is the basic idea in that. That's what I'm trying to tell you. Okay, so yeah, that was all for this particular video. This I've written overall. Okay, see, there are multiple things that they have to assume multiple things, then maybe you can, write it as in different way, like k log n or something like that. But yeah, I'm writing this one overall. Okay, because there is no much difference given between k and n. Okay, both are almost same. They are in that I'm mentioning is, that's why I'm not taking the risk of writing k log n. But yeah, on overall it will be n log n, right? So often that was all for this particular video. And as you can see, we're using two, arrays. That's why it's so often. Okay, if you go for the sorting approach, you will need only one array. But yeah, you are sorting everything after all, right? That is not something that is correct. So we are using two arrays. I agree that, like, there are n pairs are storing both the arrays. That is true. But yeah, still here, like the sorting part, right? We are saving that much efficiency as well. Okay, we are doing that much efficient way, which, is, I can say, covering up for the extras that we have taken. So yeah, that was all for this particular video. If you like the efforts, if you like the quality, the content of this video, please subscribe to the channel. This really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot.